Okay, so this morning we begin with a lab on filtering enterprise data with access control lists. You remember on Thursday I took you through access control lists, and I told you they're mainly used for security purpose when you want to filter restricted traffic, and also to filter what we call interesting traffic if we need to apply some parameters like encryption to specific data, then we call that interesting traffic. So the learning objectives for this particular lab is establishment of basic ACL to implement source-based filtering. Then number two, establishment of an advanced ACL to implement enhanced filtering. So we know the difference between basic and advanced, and also what we call the MAC address, the layer 2 ACLs. Okay, so this is the topology. Generally here, in this particular topology, we're having 3 routers that have been interconnected over the internet. Anytime we have the cloud, you can always replace it with a switch to interconnect those particular routers. So for example, in my topology, I'm actually using a switch to interconnect R1, R2, and R3. I'm just using a switch here, doesn't need any configuration. We're just offering us the ports that we need in order to interconnect them. So other than that, we have 2 switches here, S1 and S2, which we are now going to configure as our telnet server and also FTP server. Excuse me. So that we can be able to now to configure an ACL here, allow R1 to access S1 and allow R3 to access S2, or vice versa. So really, that is what we are going to do with access control list. We're going to create an ACL on R2. So you can read the scenario later. Does anyone have a question?
Gloria from Nyanza.
Okay, is someone saying something? Joshua, are you talking to us? We can't hear you, sorry. Okay, I'll just mute you for now. If you have a question, you can raise your hand. Okay. So the first step is on preparing the environment, which I've already done. Simply setting the system names, and on the switches, on switch 1, we're supposed to create a VLAN. Sorry, a VLAN and also a VLAN interface, VLAN if interface, so that we can assign it an IP address. So as you've seen in our topology, we are supposed to assign this particular interface gigabit Ethernet 0/0/2 on S1, the IP address 10.0.4.254. So in order to do that, we have to create a VLAN if like that, and assign it an IP address. On S2, we're also supposed to create VLAN 6, then do the command interface VLAN if. Just give me a moment, I'm sorry. Okay. So again here, we give it an IP address. We give it an IP address like that. So after we've done that, we can go ahead and go to step 3. Most of the time, I advise that you don't begin with the previous a topology. You just do a new topology. So we are not going to do step 2 because we are starting with new devices. So step 3 is about configuring IP addresses for all those interfaces that you've seen on the routers. And other than that, on this particular step 3, we're also supposed to create or make the interface that we've seen on our topology, the ones that are connecting to the router. So this particular interface, gigabit Ethernet 002 on switch 1 and switch 2, we make them trunk ports so that they can be able to carry tagged frames. So here we are doing that. So we go into G002, then port link type trunk, then port trunk allow pass VLAN all. Then after we've done that, we can say that we want you to carry tagged frames that have a VID of 4. So if you have a VLAN ID of 4, then we carry you as a tagged frame. So the command is port trunk pvid VLAN 4. So we can quit. Then on S2, we do the same thing. So I have already done these configurations because these already we did in a previous lab. So I'm just showing it to you. What I really want us to concentrate on here is on ACL, access control list. So on step 4, we're supposed to configure OSPF to enable inter-network communication. As we know here, the only devices that can be able to ping each other without configuring a routing protocol is R1 can ping R3 and R2 because they are directly connected over S3. R3 can be able to ping R1 and R2 because they are directly connected. But otherwise, for R1 to be able to ping S1 and S2, for R1 and R3 to be able to ping S1 and S2, we need to configure OSPF. We need to configure routing protocol so that these networks can be shared to this particular domain, to that particular network. And also this network here can be shared to this particular domain and also this particular domain. So we need to configure a routing protocol. Again, for that, I have already done the configuration because we've configured OSPF a number of times. So on R1, we simply do OSPF or OSPF1, the area, then we advertise the network using the network command, and we use the inverse mask. Again, on R2, we go into area 0, we advertise all our interconnected networks. So the 3 networks. Then on R3, we also go ahead and advertise the particular network that we are connected to. So after that, we need to configure static route on S1 and S2. And the next stop should be the private networks gateway. So that particular gateway is this particular interface here. So for S1, it is this one. For S2, it is this one. And we are configuring them with .2. So we use that as the gateway. So on S1, we use the command IP route static, IP route static. Then we configure a default static route using the anycast address. So if you receive any packet whose entry you do not have in the routing table, forward it to this next hop, forward it to the gateway. So we do that in S1 and also on S2. So S2 will forward it to 10.0.6.2, like that. So once we've configured that, now all areas of our network should be reachable. So from R1, we should be able to ping 254. That is, we should be able to ping switch 1, and we should also be able to ping switch 2. So let's try that. As I've said, I've already done these configurations. So for example, here we are on S2, we can do display current configuration. So if we do display current configuration, we can see, for example, I've already created VLAN 6. If I do enter, we can see that I've created VLAN if6, and I've assigned it an IP address. So just showing you that I've already done these configurations. We can see that on gigabit Ethernet 0/0/2 on switch 2, I've made it a trunk port. I've done the PVID for VLAN 6, and I've allowed pass for all VLANs. So from 2 to 4094. So those are some of the things that I've done, and we can see from the display current configuration. Any other thing? Yes, this is the last one that we've done. We've also configured a static route, a static route to the gateway on switch 2. So I've already done all those configurations. On R1, I can also do display current configuration. And for example, if we want to see about the OSPF, good, we can see here. We can see that on R1, I've done OSPF1, area 0, and I've advertised that particular network 10.0.13.0. Okay, so I'll do Control C to get out of there. And now we need to test connectivity to S1 from R1. So we do a ping to 10.0.4, sorry, to 10.0.4.254. So enter. So we can be able to ping switch 1. Let's also do another ping for S2. So S2 is on 6.254. So if we do a ping, great. So we're also able to ping that. We should also be able to ping them from R3. So we can just ping S1 from R3. So ping the 10.0.4.254. Good. So we're able to ping it, and you can also ping S2. So 6. Good. So also successful. So now we go now to the real deal, which is from step 5. Now on step 5, we are supposed to configure filters using access control list. Now, before we do that, we are supposed to configure S1 as a telnet server and S2 as an FTP server. So let's just label them on our topology. So S1, we want S1 to be our telnet server. Then we want this guy here to be our FTP server. FTP server. Okay. So we go into S1. We go into system view. Please mute your mic. So to configure telnet server, we have to enable telnet on system view. So telnet server enable. Oh, I misspelled enable there. Enable EN. Then we use the command user interface VTY to create the interfaces, the telnet interfaces. So now we've created that. Now the other command that you're supposed to do is to enable all the protocols to be able to use this particular interface. So protocol inbound all. Then we choose an authentication mode. Sorry, authentication mode password. Authentication mode password for this particular telnet interface that we are creating. Then we do set authentication password cipher. Then we specify the password Huawei123. So authentication mode password. Then set authentication password cipher Huawei123. So enter. So once we do that, we've created the VTY interface that we are going to be connected to when we telnet into this telnet server. So let's also do Control C. Let's also configure S2 as the FTP server. Again, just like telnet FTP, you have to enable on the system view. So FTP server enable. After you've done that, you have to create the FTP user. So we are going to use AAA. So AAA local user, the username, then password cipher, then we use Huawei123 for the password. After creating this particular person, we do the privilege level. So local user Huawei privilege level 3. We know that privilege level 3 is the management level. Then we also want to enable the FTP service for this particular user. So local user Huawei, then we do service type FTP. Then after that, you remember for FTP, we have to set the default working directory. So that is where this particular user will be landed, the folder that this person will be landed to. So local user Huawei FTP directory flash /. So meaning that this guy, if the Huawei user accesses this particular FTP server, they'll be landed on the flash directory. Okay, so that is all. So now we have S1 as our telnet server and S2 configured as our FTP server. So after we've done that, now let's look at the next thing that we're supposed to do. We're supposed to configure an access control list on R2 to allow R1 to access the telnet server and R3 to access the FTP server. I think someone's mic must be on. It's Joshua again. Okay, I've just muted you, so please don't unmute your mic unless you have a question. Okay, so let's evaluate this particular command. So we want R2. Remember, R2 is this particular router here. So we want to configure an ACL here to allow R1 to access the telnet server, to allow R1 to access S1, which is the telnet server, and R3 to access the FTP server. So that is what we want to do on R2. So the command is ACL 3000. What does 3000 tell you? That this is an advanced ACL, so we can use a number of parameters like the source, destination, port numbers to specify the rules here. So the first rule here, let's evaluate it. So rule 5, permit TCP source. So whoever has a source address of 10.0.13.1, then when we have all zeros, 0.0.0.0, it means this address should match the entire address should match as it is. Everywhere we have a 0, that particular octet must match as it is. So it is important. So here we are just allowing a single IP address, which is 10.0.13.1. So we want to allow it if the destination, if it is destined to switch 1. Are you seeing? If it's destined to switch 1. Remember, this is R1. So if R1 is destined to R1, and the destination port is port 23, is equivalent to port 23. Port 23 is the well-known port for telnet. So here we are simply allowing R1 to be able to access. We are allowing R1 to be able to access the telnet server. So I hope that rule is clear. The next one is rule 10, permit TCP source, the same thing, but now we are allowing R3 if it's going to the FTP server. If it's going to the FTP server, then the destination port, here we use destination port range instead of EQ, which is equivalent. So range, we are using 20 space 21 because we know FTP uses TCP port 20 and 21. So we need to allow both ports when we are creating the rule. So here we are simply saying R3 can be able to access, allow R3 to access the destination, the FTP server on port 20 and port 21. We know that port 20, one of them is used for the connection and the other one for the data transfer. I can't remember which one. Okay, then rule 15, another rule here, we want to permit OSPF so that on R2, it can be able to share the OSPF, the OSPF networks that have been advertised. Then the last one is a rule to deny every other packet. So unless we have permitted you, we are simply going to drop you. So rule 20, deny IP source any. So that rule is doing exactly that. So let's do this. Let's do this. So we're supposed to do that on R2. So we go to system view, we create ACL 3000, sorry, ACL 3000. Then we create rule 5. We want to permit source 10.0.13 .1 0.0.0 if it's going to the destination. So destination 10.0.4.254 0.0.0 like that. Then if the destination port is equivalent to 23. Wrong parameter. Where? Okay. Let me just check that once more. Destination. Okay. Let me just are you seeing anything that I've mistyped maybe? The 0.0 destination. Rule 5 permit source. Destination. Okay, what might be the issue? Maybe there's something that I have. Let me just try it again. So rule 5, permit source 10.0.13.0 destination 10.0.4 the 254 0.0.0 destination port EQ 23. Let me see, question mark, wrong parameter found. Wow.
What's that EQ?
Let me see. But it had worked earlier. What's the problem? Kuna kitu na mistype labda in terms of spelling. Destination. There must be something that I'm not doing right. Oh, TCP. That's the word. TCP, sorry. That's the word that I'm leaving out. Okay. So rule 5, permit TCP source. Sorry, that is what I was leaving out. .1, 0.0.0, destination 10.0.4.254, 0.0.0, destination port equivalent to 23 EQ. Oh, good. So then we do rule 10. So rule 10, permit TCP source 10.0.13.3, 0.0.0, destination 10.0.6.254, 0.0, then destination port. Here we are using a range for FTP, so we specify 20 and 21. Then we do rule 15, permit OSPF, so that the networks advertised by OSPF can be shared, and rule 20 to deny any other IP source. So rule 20, deny IP source any. So if we do display this, we can see all the rules that we have entered into this particular ACL. Rule 5, 10, 15, and 20. So we can quit. The next thing we're supposed to do, as you can see in the background here, is to apply the ACL to the interface. So we're supposed to apply the ACL on this particular interface on R2, so that if a packet is coming from R3 or R1, then they're going to be checked at that particular point on whether they're supposed to be discarded or forwarded. Okay, so here we go to the interface, int 0/0/0, Then we do traffic, traffic filter, inbound. We map it to ACL 3000. So any traffic that is coming in, apply ACL 3000. So that is what we are doing there. Okay, so let's go ahead and check the next one. So now verify the results of the access control list on the network. Okay, so let's telnet from R1. So now we want to telnet from R1 to the telnet server. So let's do that. So we do telnet 10.0.4.254. So Huawei 123. So we can see that when we do that, the prompt now changes to S1 because we have now telnetted. We are now in S1 really. Yeah. So indeed, it shows that R1 is able to telnet to S1. So I can do quit in order to go back to R1. So now we are in R1. So the next thing we're supposed to test is the FTP. The FTP. So let's try and FTP from R1. Let's see if R1 can be able to. Can R1 be able to access the FTP server S2? From the rule we've configured here, it's not supposed to. So now let's test it. So FTP 10.0.6.254. So it's trying. It takes about 60 seconds. So we have to be a little bit patient before we get the results. We expect it to fail. So as that one is trying, let's go and test R2. Then we're going to come back to that. So not R2, R3, I'm sorry. R3. So generally R3, we've configured R3 to be able to access the FTP server. So let's FTP there. So FTP 10.0.6.254. So you see, we are being asked for a username, Huawei, a password, Huawei 123. So you see, we've now FTP'd, we've connected to the FTP server. As you can see, our prompt. So R3 is able to access our FTP server, but R1, so we've not gotten the results yet. It takes a little more time. Okay, so we can see that R1 cannot be able to access the FTP server because of the ACL that we've configured on R2. But this guy, R3, is able to access it. So let's quit. Let's try and telnet from R3 to the telnet server. Generally, from the ACL we've configured, it's not supposed to be able to access the telnet server. So if we do telnet from R3 to the telnet server, we expect it to fail. Again, it takes a little bit of time, so we can move on. We can move on and see. Okay, so I think really that is it. So you can use the buy command to close the FTP connection, or you can use the quit command in order to do that. So ladies and gentlemen, that is the end of this particular lab. I hope you've seen and appreciated how access control lists work in order to control the access of different resources in your network, like servers. So here we used the advanced ACL in order to do that. So we expect this to fail. It's going to fail any moment from now. Then we can go to the next lab. which is the next lab is on network address translation. Okay, great. So this one has also failed. So R3 cannot be able to access the telnet server. Again, because of the ACL that we've just configured. So for example, in R2, can we do display ACL? Let me just see, ACL 3000. Okay, so in R2, if we do display ACL 3000, you can see it has 4 rules, and we can see the number of matches. For rule 5, the number of matches for rule 10, 13 matches. The number of matches for the OSPF rule, rule 15, and the number of matches that have been denied. So those are some of the things that you can see. So that's the end of this lab. Asanteni sana.